Recently, massive flooding, multiple landslides, and strong winds that have swept across Malaysia must serve as a wake-up call to the country to rethink the environmental impact of the construction of highways and other infrastructure projects. Malaysia's existing infrastructure hasn't been built to deal with natural disasters which we are facing this century. New and replacement highways must be built to be resilient to future climate disruption. What is resilience? Resilience is the ability to recover quickly and resume an original level of service after damages caused by climate change, pandemics, natural hazards, socio-economic, and financial shocks. When building the highways construction project, there are many challenges that need to be taken into account through the whole life cycles of the project. At the planning stage, it is important to obtain as such information as possible. For example, the use of a copy of the project or 3D modeling may cost a lot more than paper plans, but they help engineers and planners to find many different risks that may not be so easily visualized and can only be spotted when viewed through such high detail models. The models can help identify key flood-prone zones so better planning can be put in place. So whilst expensive, planning is important to avoid issues later on, which will increase maintenance costs and thus lower the resilience of the infrastructure. Through the use of nature, we can also add to the resilience of the infrastructure. A good example is to restore ecosystems like establishing trees on areas cleared for the roads projects. The tree coverage will help with water absorption by the soil rather than having the water flow over the soil. In this regard, less soil erosion will take place and in which turn leads to less likely landslides. As such, this will make the infrastructure more resilient than when the likelihood of landslides is lowered and disruption of road usage is reduced. The ecosystem services approach, which calls for the provision of green bridges, can also help to reduce accidents involving wild animals. These bridges will allow animals to move easily and safely from one area to another without accidents and with other road users, and help plant species to spread. This gives animals more spaces to find food and shelters and allows population of the same species to interact, improving the overall resilience of the species and the resilience of the infrastructure with less road closures due to accidents. Predictive maintenance is also an extremely valuable asset in improving the overall maintenance of and reliability of an operation. The goal of predictive maintenance is the ability to first predict when highway or bridges failures may occur, followed by prevention measures which are regularly scheduled. This will reduce the amount of corrective maintenance needed. Additionally, if data analysis shows certain paths that are key nodes of transport network, then more focus should be spent on those points. With collected data, they can do preventative maintenance, which is much cheaper from a lifecycle cost perspective compared to fixing things when breakdowns happen. For example, summer paving can be done on key areas which may prevent potholes from happening, which will require longer closure during peak use time. Preventative maintenance can be done during off-peak times like evening or the middle of the night. The lack of resilience to ongoing operations and maintenance of a highway is a crucial issue. When we build back, it must be better than it was originally and friendlier environmentally. Monitoring the whole life of an asset are similar to or greater than the initial capital costs, as well as costs of climate change adaptation and mitigation activities. However, every dollar we invest today in preventing disaster resilience will save a lot in the future. In conclusion, when grey building solutions are combined with green natural solutions, resilient communities emerge, poised to meet the challenges